Class 11th Chemistry Unit 5 States of Matter, and in this video we will discuss about ideal gas equation and density and molar mass of gaseous substance. First come to ideal gas equation. We discussed the gas laws in the previous videos. According to Boyle's law, volume and pressure are inversely related to each other like this at constant T and N. In the same way, according to Charles' law, volume and temperature in Kelvin scale directly related to each other, providing P and N constant. According to Avogadro law, volume is directly proportional to N amount of gas, providing P and T constant. Now, if we combine these three laws, then we will get V is directly proportional to Nt by P, and this can be written as V is equal to R Nt by P, and if we rearrange this equation we will get PV is equal to nRT. This equation PV is equal to nRT is known as ideal gas equation. R is called gas constant. It is same for all gases. Therefore, it is also called universal gas constant. And from this equation, we can write R is equal to PV divided by NT. Now, what is the value of this R? To find out the value of this R, we consider the STP condition. Okay, that is standard temperature and pressure. Pressure is 1 bar, that is equal to 10 to the power 5 Pascal. And this is volume. Volume of 1 mole of gas is 22.71 liter. Convert this into meter cube. You will get 22.71 into 10 to the power minus 3 meter cube. And N is equal to 1. That is 1 mole. And temperature is 273.15 Kelvin. If we solve it, we will get 8.314 Pascal meter cube per Kelvin per mole, or 8.314 into 10 to the power minus 2 bar liter per Kelvin per mole, and this is equal to 8.314 joule per Kelvin per mole. This is the SI value. Okay, this is the value of R in SI unit, 8.314 joule per Kelvin per mole. You have to remember this value of R. At STP conditions used earlier, means temperature is 0 degrees Celsius, that is a 273.15 Kelvin. Use the temperature in Kelvin, and pressure is 1 atm. Then value of R will come 8.20578 into 10 to the power minus 2 liter atmosphere per Kelvin per mole, and you can also write this 0.082 liter atmosphere per Kelvin per mole. Okay, ideal gas equation describes the state of any gas. Therefore, it is also called equation of state. Now, combined gas law. If temperature, volume and pressure of a fixed amount of gas vary from T1, V1, P1 to T2, V2 and P2, then we can write P1 V1 divided by T1 is equal to nR as per ideal gas equation. In the same case, we can also write P2 V2 divided by T2 is equal to nR, and this term both are equal. That's why we can write P1 V1 divided by T1 is equal to P2 V2 divided by T2. This relationship can also be derived in another way. Now, if we consider any gas having pressure is P1, volume is V1 and temperature is T1. Now, at the constant temperature, if we change the pressure, then pressure becomes P2, and suppose its volume becomes Vx, and there is no change in temperature. Okay, now at the constant pressure, If we change the temperature, then this becomes T2, and then volume will also change, and this becomes V2, and this change is taking place at the constant pressure. Now we can say this is as per Boyle's law, because temperature is constant. That's why we can write P1 V1 is equal to P2 Vx, and then Vx is equal to, this is P1 V1 divided by P2. Okay, and this change from this to this is taking place at constant pressure. That's why this is according to Charles law, and from according to Charles law we can write Vx divided by T1, this is equal to V2 divided by T2, and from this you can write Vx is equal to T1 V2 divided by T2. Now this term is equal to Vx, and this is also equal to Vx. That's why we can write P1 V1 divided by P2, and this is equal to T1 V2 divided by T2. Now just rearrange it, then we will get P1 V1 divided by T1, and this is equal to P2 V2 divided by T2. Same relationship. Okay. Now in this relationship there are 6 variables. If out of 6 values of 5 variables are known, the value of unknown variable can be calculated from this equation. This equation is known as combined gas law. P1 V1 divided by T1 is equal to P2 V2 divided by T2, combined gas law. Now see, one question is there. At 25 degrees Celsius and 760 mm of mercury pressure, a gas occupies 600 ml volume. What will be its pressure at a height where temperature is 10 degrees Celsius and volume of the gas is 640 ml? Now first thing, what are the given in this question? Temperature T1, this is given in 25 degrees Celsius. This is given in degrees Celsius. Convert this into Kelvin by adding 273. You will get 298 Kelvin. And at this temperature, pressure, that is P1 is 760 mm mercury, and volume is V1 600 ml. Then temperature T2, this is 10 degrees Celsius. Convert this into Kelvin by adding 273. You will get 283 Kelvin. And at this temperature, volume is 640 ml. Then we have to find out pressure P2. Then according to combined gas law, P1 V1 divided by T1 is equal to P2 V2 divided by T2, and we have to find out the P2. Okay. Then put the value. P1 760 mm Hg, V1 600 ml, T2 283 Kelvin, T1 298 Kelvin, V2 640 ml, and if you solve it, we will get 676.6 mm of mercury. This is the pressure. Okay. Density and molar mass of a gaseous substance. This is the ideal gas equation. PV is equal to nRT, and where this n is the number of moles, this can be found out by using this relationship small m divided by capital M, where this small m represent the mass of gas in gram and m represent the molar mass of a gas in gram per mole. If you put the value of n, then we will get PV is equal to m small m divided by capital M into RT. Just rearrange. This is P is equal to this V will come this side, then we'll get M by V into RT by M, and this is M by V, mass by volume. This is density. That's why we are having P is equal to dRT by M. Okay, and you can also write M is equal to dRT by P, and from this relationship we can say density of a gas is directly proportional to its molar mass. Okay, this is the density and this is molar mass. They are directly proportional. Okay, thank you. Subscribe my channel to get the new videos.